Welcome back to Jackson Square. Today we're going to talk about non-proportional relationships, and we're still talking about TEAC 6.6c, 6.4a, 6.6a. That has to do with being able to compare the rules and know the verbal, numerical, symbolic, and graphical representations when we have equations in the form of y equals x plus b or y equals k times x, being able to decipher between an independent and a dependent, all of those good things. So let's jump right into non-proportional. Of course, non-proportional will be different from proportional, but there'll be a few things that are still the same. So a non-proportional is still a linear equation, which means it's going to still be a straight line on the graph, right? Non-proportional relationships are when two quantities do not have the same ratio, right? Ratio, okay? It is going to be a straight line. It's still a straight line, okay? It's still a straight line. But it will not go through the origin. It will not go through the origin, but it will cross the y-axis. It's going to cross the y-axis at some other point. So it's not going to cross the y-axis at 0. It's going to cross at some other point, okay? Again, with non-proportional, we still have independent and dependent. Remember, an independent influences the changes of the dependent. The dependent is if the independent variable changes, so does the dependent. The dependent relies on the independent. Remember, you are a dependent of your parents. So our dependent is our y, our independent is our x. When we're talking about situations, let's look at how this would look in an equation. So in an equation, you would have the form of y equals x plus b. So just like in non-proportional, our y is our dependent. It is our output. It can also be called our range. Our x, of course, is our independent. independent. It is our inputs. It can be called our domain. Our b, now this is different, okay? Our b. This is called the y-intercept, okay? A y-intercept. It means that it's going to cross the y-axis. This is the point where the line will cross the y-axis. This is the point, okay? That's the point where it will cross the y-axis, where the line will cross the y-axis, okay? Remember, in a proportional, it always crosses the y-axis at 0, okay? 0x, 0y, like right there, right? But in a non-proportional, it's going to cross at some other point that's not 0. So I'm going to draw a little picture. So if this was my coordinate grid, and I had a non-proportional graph, of course, remember, it's going to be a straight line, but it's not going to cross here. It could cross here. It could cross down there. This would be my y-intercept. That's the point where that line is crossing the y-axis. Okay? So just to give you a visual. So this is called an additive relationship. And additive relationships are always non-proportional, just like multiplicatives are always proportional. Additive does not mean just addition, right? Just like last time, it means addition or subtraction. It involves only addition or subtraction, okay? So addition or subtraction would be called an additive relationship. So your equation could be looking like y is equal to x minus b, okay? Because it could be subtraction where y is equal to x plus b, y is equal to x minus b, okay? Always going to be non-proportional. So let's take what we just learned about additive relationships and look at our graph, okay? So let's look at our graph. In our graph, it said non-proportional relationships will not have the same ratio. They will be a straight line, but it will not go through the origin, but it will cross at a different point, okay? So for this graph, I have to tell you a story. Last graph, it kind of worked. So we're going to do, the title is going to be Kelly's Pay. Our x-axis, which is our independent axis, is going to be her earnings. Okay. And our y-axis, which always is our dependent, is going to be take home pay. Okay. So let me tell you a story about Kelly. So Kelly is a nurse. She works downtown in the medical center. If you've ever been to the medical center, you know there are lots of hospitals, lots of buildings down there, and they have lots of parking garages, okay? So because they have parking garages, Kelly can't park on the street, and they don't have free parking garages, but all they can do is give her a discount. So Kelly goes to work every day and she makes X amount of dollars, but every day she has to subtract her parking from her amount of dollars. So she has a discounted price. She only has to pay $3 a day for parking. So every day, if she makes $240, she has to subtract $3 because she has to pay for parking. So that is what a non-proportional relationship would look like. Whatever the X value is, whatever she makes that day, minus 3 would give her her Y value, right? So this would be a straight line, which it is, and it does not pass through the origin. It hits the y-axis here at -3. Well, why is it hitting at -3? Because Kelly has to pay $3 every day. So the non-proportional table and the non-proportional graph looks totally different from proportional. It's still going to be a straight line, but it's not going to pass at the origin here. It's going to pass somewhere else on the y-axis. So we're going to make a big note here that says does not pass through origin, okay? So non-proportional does not pass through the origin. Does not pass through the origin. So this is the story of Kelly's pay. This point where it passes is our B. It's called our y-intercept. We talked about this in the equation box. This is our B. That would be our B. So in our equation, which we're about to see in a second, here in our process column, it would be x minus 3, right? Y is equal to x minus 3. That would be our equation because we're subtracting 3 every single time. That's what we're going to do. So again, remember, the left side is always your x. It's your independent. It's your input. The right side is your y. It's your dependent. It is your output, right? Your output is the base on your input. If you don't study for the test, you can't expect to pass it, right? If I study a lot, then I expect to pass it. That's my output. A good grade on the test is an output from me studying and coming into tutorials and putting in work. So here in this process column, it says whatever that x is, I'm going to subtract 3. So if Kelly doesn't make any money for some odd, weird reason, in this situation, she still has to pay for parking. I don't know. She got in trouble that day. They say we're deducting this cost. Okay, she broke something. So she still had to pay for parking. Let's say Kelly made $2. So then this particular day, she ain't even making, she negative $1, right? So Kelly makes $4 this day. Then she's gonna be bringing home $1. Kelly makes $6, subtracting that parking, she makes $3. So this is just a little situation to show how this would look. And again, we could do those ordered pairs, 0, -3, 2, -1, 4, 1. Okay, so we were putting our ordered pairs together. 4, 1, 6, 3. So these are our ordered pairs. If we did not have a graph and we had to use a table, I could take these plot points on my coordinate grid and connect them to make my graph, right? So just like last time I showed you some things, I want to show you some things this time. Last time we saw that when x was 0, y was 0. In an additive relationship, when x is 0, y will not be 0. Okay? It will not be 0 because it's not proportional. It's not going through the origin. You're always going to have some random number here. Again, that number is your y-intercept. That number is your B. That's that point where it's crossing the y-axis, right? So here things will just look a little bit different. Remember, in an ordered pair, it's always X first, then Y, X comma Y. This is always X, this is always Y. The process column is just so you have that time to think. But in a typical one, you would just have, X and Y, right? X is always on the left, Y is always on the right. That is standard all the time, okay? Independent, dependent, input, output, okay? So looking at the equation, again, I told you it would be y is equal to x minus 3 because whatever the input is, you have to subtract 3 to get the output. So this would be our equation for this situation, talking about Kelly's pay that she's bringing home. So hopefully this helps and it kind of makes a little sense between proportional and non-proportional, but if you're not quite there yet, it's okay because we're going to have lots and lots of practice with multi-representations. So let's go practice now. Good luck.